This is a linear function. I know it's linear because the exponent on the variable is a 1. So if it's 1, it's linear. That means we're going to get a straight line. Now, to get a straight line, I really need only 2 points, but I'm going to get 3 just to make sure they all lie on the straight line. 3 is a check. So let's build a table. I'll do that right down here. Here's my x, and here's the f of x. All right, so let's choose some x values. An easy one to choose is 0, because if you put 0 in, you see what happens? If you put 0 in here, 1/4 times 0, or 0 times anything is 0, and you just get 4. All right, so that's an easy one to work with. But here's what I would get. I would get 1/4 times 0 plus 4. Okay, 1/4 times 0 is 0 plus 4, which is 4. All right, now I'm going to write one more thing here. I'm going to write an ordered pair. Here's x, f of x. So if I put in 0, I get out a 4. Let's plot that. So I'm going to come over here to the origin, and if I put in 0, I get out a 4. Now 4 is right here. All right, so let's plot a point right there. Now pick a number, another number. You can pick any number you like, but look, here's what we're dealing with. I have 1/4 x plus 4. I got a denominator here of 4. Now if I put like a 3 in here, I'd have to have 3/4. That's awkward. Why don't you put any number that is a multiple of 4? Like put in 4, because the 4s would cancel. Or 8. 4 and 8 would be 2. 2 times 1 is 2. So pick some multiple of 4. So I'm going to put in, how about 4? So let's just put in a 4. So if I put in a 4, I'll get this. 1/4 times 4, 1/4 times 4 plus 4 equals, now, when I do this, the 4's cancel. I get 1 plus 4. I get a 5. All right, so here's the point. I put in a 4. I get out a 5. Let's graph it. Let's plot that point. So if I go over 4, right, go over 4, I'll go up 5. All right, so that is going to put us right here. That's pretty tight. Okay. Now I could try another number. Why don't we try 8? So I'm going to put in an 8. Now if I put in an 8, I'll get 1/4 times 8 plus 4. So you see what I'm doing here? I'm putting the 8 into, I'm going to draw it all the way up here. Here's our function. I'm replacing all the x's. If I put an 8 here, I have to put 8 everywhere I see an x. So I'll get 1/4 times 8 plus 4. Now, what happens? Well, 4 will go into 8 twice. I get 2 times, 1 times 2 is 2 plus 4. So now I'm at 2 plus 4, so I'm at 6. Let's plot that point. So I'm going to go to the right 8, up 6. So to the right 8, there's 5, 6, 7, 8, up 6. Looks like it's right here. I'm kind of missing it here. 8 is kind of over here. Okay, so anyway, now I'm going to pass a line as best I can through these points. All right, and I'm going to claim this is the graph of f of x. Now, in problem 7, we want to graph this function, and they're giving us some to choose from. This one, this one, this one, and then this one. Now, look at these. They all seem to have a basic shape, right? This one kind of goes like this. This one kind of does the same thing, goes like that. This one does the sort of the same thing. This one does the same thing, but backwards. All right, so I think we just need a few points to see where we're going to land. Let's make a table. So here's a table. Here is x. Here is f of x equals, I'll write it here, square root of x plus 7. Okay, and then I'll even write it over here. Here is our ordered pair, x and f of x. Let's start with a 0. Put in a 0. So we'll get f of 0 is square root of 0 plus 7, which is square root of 7. Well, I can do the square root of 7 on my calculator, but just get an estimate. What numbers do you know square roots of? Well, you know square root of 4 is 2. Now, 4 is just below 7. So 4 is below 7, so square root is 2. So this is going to be bigger than 2. The next one I know is 9. 9 is bigger than 7, and that square root is 3. This is somewhere between 2 and 3, so it's going to be 2 point something here. Now, do any of these graphs look like it could be? Go to 0 and then up about 2. So go over to this graph. If I go to 0, well, this one I'm going to rule out because I don't go up or down. Nothing hits that one. All right, what about this one here? Well, this looks like, oh, this is 20. Wow, that must mean what? 5, 10, 15, 20. Each one of these are 5s. This one's close to 10. So at 0, we're close to 10. That can't be it. What about this one over here? Well, at 0, well, look at this. You know what? I'm going to enlarge this so I can see it a little bit better. So where are we at 0? At 0, that's 5. This looks like it's between, right? 5, 10, 15, 20. This is at 0. This looks like we're up between, like 3 or 2 and 3 someplace. I think this is it. Well, now look at this one over here. This looks like it could be it too. Right at 0, we could be up there. Let me shrink this up again. So right now, I think it's between, I think we're between these two, C and D. That didn't show up very well. Between C and D. Let's get one more point. Now, I think I'm going to actually put in something I know the square root of. So I'm going to add it to 7. What if I put in a 2? So if I put in a 2, I would get the square root of 2 plus 7, which is the square root of 9, which is 3. Okay, let's go even one more. Okay, now I think I can see what's happening here. If I put in this 2, I'm up at 3. Now look at this graph over here. If you put in a 2, right, now these are 5s, right? If you put a 2, it looks like it could be up at about 3. What about this one? If you put in a 2, well, it looks like it could be at 3 again. So we got to put in another number, I think. Okay, I'm going to pick another number that if I add it to 7, I know what the square root is. So here's what I'm looking to get. I know this one, square root of 25. That's 5. Now, what do I need to put in here? Well, that's going to be an 18, all right? So I'm going to put an 18 in here. Now, if I follow this graph over, look at this one here, see. If I go over to 18, all right, 18 is close to 20. It looks like we're up at 5. Now, if I go over to this one, I can't even get out to 18. So this one is out. So we're going to claim now that that is the graph of this function.